I've decided to do a quick little video kind of in follow-up to a Flash email I've received since I've been responding to the Flash support list for a while. I mean, sometimes I ask questions too, but a lot of the questions that are sent on the Flash support list I feel like are kind of recurring, and so I thought maybe sending this video with some tips might be helpful. So first of all, so the kind of the content of this video is, or like the question received is, why is using more nodes require more time? You'd expect typically that if you throw twice as many cores, or in this case equivalently twice as many nodes at a simulation, it should take half as much time if you're keeping the problem fixed. At least that would be a good strong scaling of the code. And Flash is known for having good strong scaling, although it really depends on what physics modules you're using. And so that's kind of the main content of this question. Not going to kind of go through everything. And so, I mean, it's kind of hard to know what's going on just with the information provided. I mean, one clue is that there's HYPRE included, but it's really hard to say without knowing kind of what in detail they're running or what their log file looks like. And so I mentioned that probably there's some issue with a lot of MPI broadcasts or MPI all reduce, some global to global communication or all to all communication, which is slowing things down. But I mentioned if they attach their log files, I could look into it. And so they did so. And usually I just download these like log files, and I've never really had any problems. Now, I have my other email here, there's a lot of phishing attacks going on. And I don't know, I've never really had a problem. I don't typically download stuff that looks fishy. And in this case, they didn't upload anything until like I requested it. So that sounds, reasonable. But because of the all these phishing attacks going on, this is actually a different web service than Gmail, which maybe Gmail has a bit of a better malware scanner. I don't know. But anyway, the other nice thing about Gmail is that there's a download button, and then would be an add to drive button. I've already added these to my drive. And so if we go into Google Drive, then we can view these files without even downloading them, and then you don't have to worry about your computer. So this was called onenode.log, twonodes.log. I changed those to .text, so you'd do a control click and then rename, and then I changed them from .log to .text, and then that lets you open them. Unfortunately, it doesn't let you open them with just like a Google Doc, but you can with text editor. And the first time that you do this, it'll ask, like, are you sure you have permissions? And I clicked yes and didn't really read anything. Maybe I should have, but I don't really have anything that I'm trying to hide on here, I would say. Okay, and then we'll open up the other one in text editor. And then you can at least like run through it and make sure that it just looks like a normal Flash log file before downloading. And it does. So I did end up downloading them, and I ran a diff, which just makes life a lot easier. But even without doing that part, if you scroll to the bottom, so with the Flash simulation code developed by University of Chicago, I guess now the Flash Center is at Rochester. I don't really know what happened there, but anyway, ignoring the legal drama. So towards the end of the Flash log file, there's this accounting unit, and it tells the percentage of time used in different modules in Flash. And so 99.594% of the wall time was spent in the evolution part, which is good because you don't want initialization to take up too much time. And I believe that that is also the case for the two-node case. We're going to scroll back up. And then there's also some additional information here about how many calls each like routine received. And that's might also kind of help understand like what's going on. But I at least start by looking at the percentage of time. So again, evolution takes up the vast majority of the case in the one node case, and then we were previously looking at the two node case. So let's continue with the one node case. And inside of evolution, what takes up the most time, it looks like radiative transfer module takes up 47% of the time. So definitely a significant chunk. And then, so this is inside of the evolution thing. It'd be nicer if it was tabbed a little bit more. But I also kind of like using two spaces, so I don't blame them too much. Diffuse did not take very much time. Source terms is the other thing that took a good chunk of time. And within source terms, energy deposition took up most of the time. So these numbers are always percentage of the total. So 35 being pretty close to 36 means that this took up a good chunk of the source terms time. And that maybe that's a little confusing, but you get used to it. And then inside of energy deposition, transport rays took up most of the time. Okay, so source terms taking up 36% of the time. How is it for the two node case? In the two node case, radiative transfer took 74% of the time. So that sounds like a lot. And previously we had 47%. So that's not quite double, but it is larger than in the one node case. And then grid advanced diffusion took up 70% of the time. And so that is a little bit more than twice the time in the one node case now. So probably, I don't really know the details of the radiative transfer routines or module in Flash because I haven't used them. But this is suggesting that there's some global communication going on or some inefficiencies. And more particularly, it's in the grid HYPRE solve. And maybe more particularly, it's in this HYPRE setup and HYPRE solve. So there's some issue with HYPRE, and I don't really know HYPRE that well, but it could be that similar to HDF5, where there's a serial HDF5 version as well as a parallel HDF5 version. So often in like massively parallel simulations, file I/O can really dominate, especially if you have a ton of processors that are waiting to do their file I/O. And so doing a HDF5 in parallel can really improve that efficiency. And so there might be a similar problem with this user's HYPRE installation, that it's not parallelized. Or it could be something that's a problem in their implementation, although I think that they mentioned that they didn't tweak anything. So it could also just be an inefficiency in the current versions of these routines in Flash. Now back to their email, I think that they mentioned that they do cylindrical geometry, which also I haven't used, so I don't know for sure, but it could be that that's kind of inefficient. And then one other thing to look at is, okay, between the one node case and the two node case, if they only have like 40 blocks that they're using, then obviously two nodes won't be any faster than one node. It shouldn't be slower in that case. So I do think that there's an issue with the communication. If we look for tote leaf blocks, starts out as 40, and then it must have like AMR on. So it goes up to 560, close to 600. It's around 500 to 600. So that's pretty small, especially for a 2D problem. But I mean, there is radiative transfer going on, so maybe it's slow enough already. And so for the two node case, pretty similar, also around 500 to 600. So it could be that you just don't expect that good of a parallel efficiency with this many blocks. And they did have NXB and YB as 16, so they could easily double the number of blocks that they have just by setting these to 8. Oh, and then dash max blocks equal to 1,000. So yeah, so this means that each processor could have 1,000 blocks, but there's only 500, 600 blocks total, right? So this should really be set to, I don't know, it could be set pretty small. It could be set to like 30, or it could be set to 600 divided by 40 or so, or 600 divided by 80. Well, it has to be large enough that it'll work for the one node case still. But so this really maybe should be smaller. And yeah, so that's kind of my feedback looking at this problem. Hope that kind of looking at the leaf blocks, looking at more particularly the percentage of time at the end of the log file is helpful. And yeah, I'm not sure if I'll do another one of these videos or not, but especially for maybe repetitive problems or maybe like tips that I've found useful that I don't see cropping up as much, maybe I'll toss more out there in the future. Okay, hope everyone is well. Have a good day. Bye.